massive deal you announced a couple of days ago with OpenAI Stargate, where you're going to be a preferred partner, invest $100 billion in the company over a period of time. They're going to build 10 gigs. And if they used NVIDIA for those 10 gigs, that could be upwards of $400 billion in revenue to NVIDIA. So help us understand, just tell us a little bit about that partnership, what it means to you, right? And why that investment makes so much sense for NVIDIA.
So first of all, I'll answer that last question first. And then I'll come back and revisit my way through. I think that OpenAI is likely going to be the next multi-trillion-dollar hyperscale company.
Okay.
I think you and I.
Why do you call it a hyperscale company?
Hyperscale, like Meta's a hyperscale.
Yeah.
Google's a hyperscale. Yeah. They're going to have consumer and enterprise services, and they are very likely going to be the world's next multi-trillion-dollar hyperscale company. Yes. And I think you would agree with that.
I agree.
If that's the case, the opportunity to invest before they get there, this is some of the smartest investments we can possibly imagine. And you got to invest in things you know.
Right.
And it turns out we happen to know this space. Mm-hmm. And so the opportunity to invest in that, the return on that money is going to be fantastic. So we love the opportunity to invest. We don't have to invest.
Right.
And it's not required for us to invest, but they're giving us the opportunity to invest. Fantastic thing. Now let me start from the beginning. So we're partnering with OpenAI in several projects. The first project is the build out of Microsoft Azure, and we're going to continue to do that. And that partnership is going fantastically. We have several years of build out to do, hundreds of billions of dollars of work just to do there.
Right.
The second is the OCI build out. Mm-hmm. And I think there's some 5, 6, 7 gigawatts that are about to be built out. And so we're working with OCI and OpenAI and SoftBank to build that out.
Right.
Those projects are contracted. We're working on it. Lots of work to do. And then the third is CoreWeave, right? And so all of CoreWeave 4, I'm talking about OpenAI still.
Yes.
Okay. Everything in the context of OpenAI. And so the question is, what is this new partnership? This new partnership is about helping OpenAI, partnering with OpenAI to build their own self-build AI infrastructure for the first time.
Right.
And so this is us working directly with OpenAI at the chip level, at the software level, at the systems level, at the AI factory level, to help them become a fully operated hyperscale company. I mean, this is going to go on for some time. It's going to supplement the amount of, they're going through 2 exponentials, as you know.
Right.
The first exponential is the number of customers is growing exponentially. Right. And the reason for that is the AI is getting better, the use cases are getting better, just about every application is connected to OpenAI now. And so they're going through the usage exponential. The second exponential is the computational exponential of every use.
Yes.
Right?
Yes.
Instead of just a one-shot inference, is now thinking before it answers. Yes. And so these 2 exponentials compounding their compute requirements. And so we got to build out all these different projects. And so this last one is an additive on top of everything that they've already announced, all of the things that we're already working on with them. It's additive on top of that. And it's going to support this incredible exponential.
The one that was probably most profound for me was you pounding the table. That, remember at the time, there was kind of a slump in terms of pre-training. And people were like, oh my God.
The end of pre-training.
Right, the end of pre-training. Yeah. We're overbuilding.
Yeah.
This is about a year and a half ago.
Yeah.
And you said, inference isn't going to 100x, 1,000x. It's going to 1 billion x. Which brings us to where we are today. You announced this huge deal. We ought to start there.
I underestimated. Let me just go on record. I underestimated. We now have 3 scaling laws, right? We have pre-training scaling law. We have post-training scaling law. Post-training is basically like AI practicing.
Yes.
Practicing a skill until it gets it right. And so it tries a whole bunch of different ways. And in order to do that, you've got to do inference. Yes. So now training and inference are now integrated in reinforcement learning. Really complicated. Yeah. And so that's called post-training. And then the third is inference. The old way of doing inference was one shot.
Right.
But the new way of doing inference, which we appreciate, is thinking. So think before you answer.
Yeah.
And so now you have 3 scaling laws. The longer you think, the better the quality answer you get. while you're thinking, you do research, you go check on some ground truth, and you learn some things, you think some more, you go learn some more, and then you generate an answer. Don't just generate right off the bat. Right. And so thinking, post-training, pre-training, we now have 3 scaling laws, not 1. So first of all, for the builders, we're supposed to be building for opportunity.
Right.
We're builders. Let me give you 3 points to think through. And these 3 points, it'll help you, hopefully, be more comfortable with NVIDIA in this future. So the first point, and this is the laws of physics point. This is the most important point, that general purpose computing is over, and the future is accelerated computing and AI computing. Yeah. That's the first point. And so the way to think about that is there's how many trillions of dollars of computing infrastructures in the world that has to be refreshed.
Right. And when it gets refreshed, it's going to be accelerated computing.
That's right. And so the first thing you have to realize is that general purpose computing, and nobody disputes that. Everybody goes, yeah, we completely agree with that. General purpose computing is over. Moore's law is dead. People say these things. And so what does that mean? So general purpose computing is going to go to accelerated computing. Our partnership with Intel is recognizing that general purpose computing needs to be fused with accelerated computing to create opportunities for them. Mm-hmm. Is that right? Mm-hmm. And so 1, general purpose computing is shifting to accelerated computing and AI. 2, the first use case of AI is actually already everywhere. Right. It's in search, recommender engines. Isn't that right? In shopping. The basic hyperscale computing infrastructure used to be CPUs doing recommenders, is now going to GPUs doing AI. Right. So you just take classical computing, it's going to accelerated computing and AI. You take hyperscale computing, it's going from CPUs to accelerated computing and AI. And then now that's the second point. Just feeding the Metas, the Googles, the ByteDances, the Amazons, and take their classical, traditional way of doing hyperscaling and moving into AI, that's hundreds of billions of dollars. Now, the incredible thing is, when you go to AI, when you go to accelerated computing, then what happens? What are the new applications that emerge as a result? And that's all the AI stuff that we're talking about. Yeah. And that's that opportunity. What is it? What does that look like? Well, the simple way of thinking about that is where motors replaced labor and physical activity, we now have AI, these AI supercomputers, these AI factories that I talk about. They're going to generate tokens to augment human intelligence, right? And human intelligence represents what? 65% of the world's GDP. Let's call it $50 trillion. And that $50 trillion is going to get augmented by something. And so let's come back to a single person. Suppose I were to hire a $100,000 employee, and I augmented that $100,000 employee with a $10,000 AI. Yes. And that $10,000 AI, as a result, made the $100,000 employee twice more productive, 3 times more productive. Would I do it? Heartbeat. I'm doing it across every single person in our company right now, right? They all have co-agents. That's right. That's right. Every single software engineer, every single chip designer in our company already has AIs working with them. 100% coverage. Yeah. As a result, the number of chips we're building is better. The number is growing. The pace at which we're doing it is right. And so we're growing faster as a company. As a result, we're hiring more people. Our productivity is greater. Our top line is greater. Our profitability is greater. What's not to love about that? Now, apply the NVIDIA story to the world's GDP. And so what's likely to happen is that $50 trillion is augmented by, let's pick a number, $10 trillion. That $10 trillion needs to run on a machine. Now, the reason that AI is different than IT in the past, in a way, software was written a priori, and then it runs on a CPU. And a person would operate it. In the future, of course, AI is generating tokens, but a machine has to generate the tokens, and it's thinking. So that software is running all the time, whereas in the past, the software was written once. Now the software is, in fact, writing all the time. It's thinking. In order for the AI to think, it needs a factory. And so let's say that $10 trillion of token generated, 50% gross margins, and $5 trillion of it needs a factory, needs an AI infrastructure.
Right.
So if you told me that on an annual basis, the CapEx of the world was about $5 trillion, I would say the math seems to make sense.
Yeah.
And that's kind of the future, right?
Yeah.
Going from general purpose computing, accelerated computing, replacing all the hyperscales with AI, and then now augmenting human intelligence for the world's GDP. We have to, unless we increase the performance at incredible rates, the cost of token generation will keep growing because Moore's law is dead, right? Because transistors basically cost the same every single year now. And power is largely the same. And between those two fundamental laws, unless we come up with new technologies to drive the cost down, even if there's a slight difference in growth, you give somebody a discount of a few percent, how's that going to make up for two exponentials? And so we have to increase our performance annually at a pace that keeps up with that exponential. So in the case of going from Kepler to all the way to Kepler, all the way to Hopper was probably 100,000x. That was the beginning of the AI journey for NVIDIA. 100,000x in 10 years. Okay, between Hopper and Blackwell, we increased because of NVLink 72, 30x in 1 year. And then we'll get another X factor again with Rubin. And then we'll get another X factor with Feynman. And the way we do that is because the transistors aren't really helping us very much, right? Moore's law is largely, the density is going up, but the performance is not. And so if that's the case, one of the challenges that we have to do is we have to break the entire problem down at the system level and change every chip at the same time and all the software stack and all the systems all at the same time. The ultimate extreme co-design. Nobody's ever co-designed at this level before. We change the CPU, revolutionize the CPU, a GPU, the networking chip, the NVLink scale up, the Spectrum X scale out. I heard somebody said, oh yeah, it's just Ethernet. Yeah, right. Okay, so Spectrum X Ethernet is not just Ethernet, and people are starting to discover, oh my God, the X factors is pretty incredible. You know, NVIDIA's Ethernet business, the just Ethernet business, is the fastest growing Ethernet business in the world. And so scale out, and of course now we have to build even larger systems, so we scale across multiple AI factories connected together. And then we do this at an annual pace. And so we now have an exponential of exponentials going ourselves from technology, and that allows our customers to drive the cost of tokens down, keep making those tokens smarter and smarter with pre-training and post-training and thinking. And as a result, when the AI gets smarter, they get more used. When they get more used, they're going to grow exponentially.
The argument you've made that kind of shocks some people, where you say our competitors building ASICs, they could literally, all their chips are cheaper already today, but they could literally price them at zero. Our objective is they could price them at zero, and you would still buy an NVIDIA system because the total cost of operating that system, power, data center, land, etc., the intelligence out is still a better bet than buying a chip, even if it's given to you for free.
Because the land, power, and shell is already $15 billion.
So we've taken a crack at kind of the math on that, but walk us through your math, because I think for people who don't spend as much time here, that it just doesn't compute. How could it possibly be that you were pricing your competitors' chips at zero, given the expense of your chips, and it still is a better bet?
There's two ways to think about it. One way is, let's just think about it from a perspective of revenues. Okay, so everybody's power limited. And let's say you were able to secure 2 more gigawatts of power. Well, that 2 gigawatts of power, you would like to have translate to revenues. So your performance or tokens per watt was twice as high as somebody else's token per watt, because I did deep and extreme co-design. And my performance was much higher per unit energy, then my customer can produce twice as much revenues from their data center. And who doesn't want twice as much revenues? And if somebody gave them a 15% discount, you know, the difference between our gross margins was, call it 75 points, and somebody else's gross margins, call it 50 to 65 points. It's not so much as to make up for the 30 times difference between Blackwell and Hopper. Let's pretend Hopper's an amazing chip, an amazing system. Let's pretend somebody else's ASIC is Hopper.
Yeah.
Blackwell's 30 times. So you've got to give up 30x revenues in that 1 gigawatt. It's too much to give up. So even if they gave it to you for free, you only have 2 gigawatts to work with. Right. Your opportunity cost is so insanely high. You would always choose the best perf per watt. All the countries realize they have to get into the AI world because everybody needs to stay in computing. There's nobody in the world that says, guess what? I used to use computers yesterday. I'm pretty good with, clubs and fire tomorrow, And so everybody needs to move into computing. It's just being modernized. That's all. Okay. Number one, it is the case that in order to participate in AI, you have to encode within AI your history, your culture, your values. And of course, AI is getting smarter and smarter so that even the core AI is able to learn these things fairly quickly. You don't have to start from the ground, from ground zero. And so I think that every country needs to have some sovereign capability. I recommend that they all use OpenAI, they all use Gemini, they all use, these open models, you use Grok, and I recommend they all do that. I recommend they all use Anthropic. But they should also dedicate resources to learn how to build AI. And the reason for that is because they need to learn how to build it not just for language models, but they need to build it for industrial models, manufacturing models,
national security models.
National security models. There's a whole bunch of intelligence they have to go cultivate themselves. So they ought to have sovereign capability. Every country should develop it. And some of the things I heard, they could never build AI chips. That just sounded insane. 2, that China can't manufacture. China can't manufacture? If there's one thing they could do is manufacture. 3, they're years behind us. Is it 2 years, 3 years? Come on, they're nanoseconds behind us.
Nanoseconds.
Yeah, they're nanoseconds behind us. And so we've got to go compete.
Yeah.
We've got to go compete. And so the question then becomes, what's in the best interest? What's in the best interest of China, of course, is that they have a vibrant industry. They also publicly say, and rightfully, I believe they believe this, is that they want China to be an open market. They want to attract foreign investment. They want companies to come to China and compete in the marketplace.
Right.
And I believe that I hope that we'll return to that in our context, answering your question, what do I see in the future? I do hope, because they say it, their leaders say it, and I take it at face value, and I believe it because I think it makes sense for China, that what's in the best interest of China is for foreign companies to invest in China, compete in China, and for them to also have vibrant competition themselves. Yeah. And they would also like to come out of China and participate around the world. Yeah. That is, I think, is a fairly sensible outcome. And what we need to do as a country is to enable our technology industry, which today is I'm privileged to be working in an industry that is our national treasure. We have to acknowledge it is our national treasure. It is our best industry. It is our single best industry. Yeah. Why would we not allow this industry to go compete for its survival? For this industry to go and proliferate the technology around the world so that we could have the world be built on top of American technology, so that we can maximize our economic success, maximize our geopolitical influence, maximize this technology industry during such a vibrant time, such a pivotal time, to allow it to thrive.